How to read science and mathematics. Science and math are two fields of knowledge that aim to describe and explain the natural world and the abstract structures of logic and reasoning that we've created as humans to understand this world. They're both fascinating and challenging, but also really rewarding and useful for anyone who wants to learn more about how things work and why they are the way they are. But reading science and math isn't the same as reading a novel or a newspaper. It requires a different set of skills and strategies from the reader, as well as a lot of patience and curiosity, a unique blend. So I'm going to share some tips and resources on how to read science and mathematics effectively and enjoyably. The scope and purpose of science and math are not just collections of facts and formulas. They're dynamic, creative endeavors that seek to discover, whether it's Marie Curie or Einstein or a contemporary like Richard Dawkins. These are curious, challenging, intuitive, seeking minds. They want to discover, invent, test, and refine the laws and principles that govern nature and logic and humanity. But they're not gods. They're just ideas. And they're interconnected and interdependent. They often use each other's methods and results to advance their own fields. For example, physics uses math to model physical phenomena, while math uses physics to inspire new concepts and structures. So when you're reading science and math, it means not only that learning established theories and results, but also understanding the context, motivation, and implications of their authors. Just like any other field, at the end of the day, it's a human that's written this. Of course, AI is a whole other story. But this also means being aware of the open questions or unsolved problems. What's the current research and the directions that drive the progress of a particular field? To do this, it's helpful to read books that provide a broad overview of the history, philosophy, and application of science and mathematics, as well as books that focus more specific topics, niches, or branches of your own personal interest. In other words, you need the fundamentals before you can get into the advanced stuff. Here's a couple examples of really great books in this category. A Short History of Nearly Everything by Bill Bryson. This is a popular science book that covers a wide range of topics from astronomy to biology, geology to chemistry, physics to psychology. And it's got an engaging and humorous style that has made Bryson a really beloved author. Next up, The Joy of X by Stephen Strogatz, a collection of essays that explain the beauty and relevance of mathematics in everyday life, from numbers to geometry, calculus to cryptography. An intrigue of my own. From probability to game theory, this is a fun book. The Fabric of Reality by David Deutsch, a book that explores the connections between four fundamental strands of knowledge: quantum physics, computation, evolution, and epistemology. A favorite of mine during my own schooling and educational time. This is the theory of knowledge itself, also a topic for IB students. The Princeton Companion to Mathematics by Timothy Gowers. This is a comprehensive reference book that covers all aspects of math, from history and culture to concepts and techniques, its applications and its challenges to its personalities and prizes, the rules and difficulties for reading science and mathematics. Unlike other types of texts, science and math often use specialized terms, symbols, diagrams, graphs, tables, equations, proofs, and experiments. And this can often feel like you're reading a whole different language, or alphabet, as the case may be. And these elements are essential for precision and clarity, but they can also be super intimidating and scary, or confusing if you don't know what they mean. So for readers who aren't familiar with them, it's really important not only that you're memorizing definitions and formulas, but also that you're understanding the meanings or implications of these intricate and precise languages. I mean, think of that graphic. Maybe I can find it where all the silly numbers come out of your head matrix style. This is what it's about. It's about being able to follow the logic and evidence of the arguments and the claims that are made in the text. It's still just analytic reading. And to do this, it's helpful to use some strategies and tools that can enhance your comprehension and also your retention of the material, so how it sticks. First up, classic reading skill, Previewing. So before reading a text, skim through it to get an overview of its structure, purpose, and main points. Look for headings, subheadings, summaries, keywords, questions. These can guide your reading, direct you to what you're looking for. Next up, annotating. So while reading a text, mark or highlight the important information, such as terms, formulas, examples, diagrams, etc., that you need to remember or understand. You can also write notes or questions in the margins to clarify or summarize the content. Next up, reviewing. So after reading a text once through, review what you've learned by recalling or writing down the main ideas in your own words. So the concepts, the results, classic note-taking, not while reading, but after, to test your own recall. You can also test yourself by answering questions or solving problems that are related to the text. Next up, supplementing. So if you encounter difficulties or gaps in your own understanding, seek additional help or resources to overcome them. Get outside of the book. You can consult other articles, websites, videos, podcasts, or YouTube videos. And these can explain the same topic in a different way or a different voice, or just simply provide more examples and exercises that will give you the practice you need to retain the concept or idea. You can also ask questions or discuss with others who are interested and knowledgeable in the topic. So seeking out peers, whether it's online or in person, who will engage with that interesting dialectic with you. The examples and exercises for reading science and math aren't just enough, though. You also need to put these into practice. So what you've learned by applying these needs to be jumped over into the real world and put on concrete situations or problems. This will help you deepen your understanding and develop your skills and discover those new insights or connections. So science and mathematics texts often provide examples and exercises that illustrate or test the concepts and methods in the text. These are valuable opportunities for learning and improvement, so don't skip them or ignore them. This is the little bar in the liner or margin notes. It's important. In other words, reading science and math means not only studying the theory, but also doing the practice. It means being curious and creative, as you can explore different scenarios or variations of the problem, or even create your own problems or challenges. To do this, it's helpful to use some resources and platforms that can offer a variety of examples and exercises for different branches and levels of science and math. So, for example, Khan Academy, a classic, a website that provides online courses and video on various subjects, including math, physics, chem, bio, etc. And this goes all the way from the kindergarten or preschool level right up to the college collegiate level. A great resource, and they've also been developing some AI tools. Brilliant. This is a website that provides interactive lessons and quizzes on logic, algebra, calculus, geo, probability, stats. I used this one myself in grad school when I was doing econ stuff. It gives you daily challenges and puzzles that test your skills and creativity. Next up, Project Euler, a website that offers a series of computational problems that involve math and programming ranging from easy to hard. Math Olympiad, a website that contains information and resources on various international mathematical competitions for students of all ages and levels. Again, put it into practice. With the math and science stuff, it has to become practical and applicable. Comment below. The playlist is over my shoulder for the next video.